All right, so what we're looking at now is, like I said, piecing everything together, all the skills we've learned together, and throwing a few new terminology here. Now, something I have talked about quite a bit is we've been solving linear equations, we've been graphing linear equations, and what a linear relation or equation represents, a linear relation can be expressed as an equation or a graph, but is an equation that when it is graphed produces a straight line. So that's why all our equations were when we graph them, they were all straight lines. They have a consistent pattern, right? Our slope is our consistent pattern of the line, which means it's going to go up and down and left and right at the exact same rate all the time. So that's why we always get a straight line. Now, there's two different types of linear relations. We have what's called direct variation and partial variation. And direct variation is a linear relation, in other words, a straight line that passes through point 0, 0, the origin. Now, partial variation, really close, is a linear relation, again, which is a straight line when it's graphed, that does not pass through point 0, 0, our origin there. So one does and one doesn't. All right. So here we go. Example 1. What type of variation does each graph represent? So again, direct variation refers to a line that passes through the point 0, 0. Partial refers to a line that doesn't pass through it. And again, if you're looking for a point 0, 0, that means you start from the origin here and you go 0 left or right and you go 0 up or down. And you can see that this point does, or this line does pass through that point. And so in this graph A, we would have direct variation. Now again, in B, I'm looking up here and I go to that point 0, 0, which again means 0 height, 0 left or right, which is right here. Well, our graph does not. It's way, way up here around 25. And so because it does not go through the point 0, 0, this would be partial variation. All right, let's try a couple more. C, again, reads earnings. So again, I look for that point 0, 0, which would mean 0 time worked and 0 pay, which makes sense, which is right there. And you can see that our dotted line goes through that point. And so once again, because it does go through our origin, our 0, 0 point, we have direct variation. All right, our last one here, D. Again, we're looking at the point 0, 0, which means 0 time, 0 height, which would be right there. And you can see that our graph does go through that point, but there's a catch. This ain't no line. This is a curve. So is it partial or direct variation? Secret answer C. It's neither. It is not linear. It's not a straight line. A little bit of a trick thrown at you there. All right. Now, as I said, we are going to be, putting all our information together. So here we go. I don't know how this is way down there, but move that up. All right. So example 2, here we go. Larry, a grade 9 student from St. Peter's, went to the Peterborough exhibition in August. The Peterborough Fair, the exhibition, same thing. The Peterborough X charges an entry fee plus a set amount for each ticket. The recorded data relating the number of rides taken and the overall cost of taking those rides is represented in the graph below. Examine the graph and answer the questions below. Okay. The first stuff is we're looking for the Y-intercept. All right, the Y-intercept. Now, again, that is where our line, which we have here, linear relation, meets the y-axis. And again, we have our y-axis, our x-axis, and our y-axis. And so if I look on our graph here where it hits the y-axis, I think it's just above that line. So I'm going to say if every block is 5 and it's just above it, I'm going to say that's a 6 that it hits there. All right. Now, again, we're trying to put some real life meaning to the situation. And so in B, it says, what does the y-intercept represent in this situation? So I look at this red point, my y-intercept here, and you can see on the x-axis, we have the number of rides, and the y is the total cost. And right here, we are at 0 rides, but yet the cost is $6. And now if I read the question again about Larry being a grade 9 student from St. Peter's, the Peterborough X charges an entry fee plus the number amount for each ticket. So if we have no rides taken, it costs $6, the y-intercept must be the entry fee is $6. Now, does this graph represent direct or partial variation? Well, again, we're looking at does the point, because it asks us to explain as well here, does the point go through 0, 0, which means 0 rides, 0 cost? No, it does not. So this would be an example of partial variation. A line does not go through point 0, 0. And that's because you have to pay an entry fee. If it did go through the point 0, 0, that's saying that you have, for 0 rides, it would cost $0. That's not true. It costs you $6 just to get in the place. And Larry here was actually a real student of mine. He wasn't happy about that. Now we get to D. And this again is tying in everything we've done so far. And that find the slope of the line and explain what it means. All right, so we're going to find the slope of this line. Now, again, you need 2 points on a graph. All right, 2 nice points are as good as we can get. So I'm going to pick this one here and this one here, the 2 green points, to find my slope. All right, and so I'm going to go over a bit and then up from point to point. Now, when I go over, I've gone 2 spaces, but that's not how much those spaces actually mean. I'm going from 5 rides to 10 rides. So in fact, my run, I've moved up 5 rides. Now, when I go up, let's see here, I'm at a height of, that's just over. Again, every block is 15, so I would say that has a height of 16. And we're going up to a height of 26. And so the difference, you can subtract those numbers. 26 minus 16 is 10. I've gone up 10. And the units on this axis are dollars. And so to find this slope, I take my $10 and I divide it by my 5 rides, and I get 2. But in fact, unit-wise, I get $2 per ride. So what does the slope represent in this situation? Sometimes these are obvious, sometimes they're not. It's the cost per ride. It costs $2 a ride. All right, now, whoa, got all this stuff down here. I got to drag it up. It says find the equation of this line. There we go. Well, again, the equation, you need the slope and you need the y-intercept. Well, there's our slope. It's 2. That's going to go right here. Our y-intercept we found initially. It's a 6. So the 6 is going to go right here. So the equation of our line is y equals, choose our slope. We have an x value. And then afterwards is the y-intercept, which is a positive 6. So there's our equation. Y equals 2x plus 6. All right, now it says use the equation to find the cost of 40 rides. All right, so if we're finding the cost of 40 rides, again, I got to figure out what that value is. So I'm going to write down my equation is, what my equation is, y equals 2x plus 6. Now, again, just like we did earlier today with solving word problems, we have a y and an x. This 40 here is one of them. It's either the x or the y. Here's how we figure it out. I go back to my graph. We got 40 rides here. Rides is on the x-axis. So it is my x value. So that is my x. So now I'm going to substitute that value in. So I have y equals, we know the x value is 40, so I'll plug that in, plus 6. All right, so the variable's already isolated because I'm solving for y, which if you look on the graph again, the y-axis is the cost. That's what we're figuring out here. All right, so doing Bedmas, I do my multiplying first. Well, 2 times 40 is 80, plus the 6. All right, then I put those two numbers together, and the cost is $86. There we go. All right, so we use we'll get to that. We use the slope and we use the y-intercept to come up with the equation, and then we actually use the equation to find a word problem. All right, I'm going to go down to G here. Use the equation to find out how many rides could be taken for $57. All right, so again, I've got my equation. I'm going to write it down. Different question, but yet again, same scenario. Now again, I got this $57. It's either the y or it's the x, but I can go up to my graph and look for money. Rides is on the x-axis. Money here, total cost, is on the y-axis. So that $57 is our y value. There's our y. All right, so I'm going to substitute in my value here. So my 57 is my y value. It's equal to 2x plus 6. All right, so, well, I do have to separate my terms here. So I'm going to get my numbers on one side, x is on the other. So I'm going to move this 6 over to the other side. And again, when it changes sides, it changes sign. So it's going to be a minus 6 is equal to 2x. All right, simplifying that, 57 minus 6 is 51 equals 2x. All right, so I've separated my variables and I've separated my terms and I've collected like terms. And so now I'm going to get x by itself. And so I'm going to divide by 2. What I do to one side, I got to do to the other here. And so 51 divided by 2 is, let's see here, x equals 51 divided by 2. We get 25.5. Whoops, x equals 25.5 rides. There we go. So we're only going to get 25 rides because, as you know, if you go to a fair or exhibition or whatever they call it, they're not going to take half a ticket and give you half a ride. So that's what they try to do to make you pay more and buy more tickets. And that's one of the things that Larry was upset about in my class many years ago. All right, I'm going to try another one here. Start all over. But again, building on the things that we've done before, finding the y-intercept, finding the slope, coming up with an equation, and then using that equation to solve problems. All right, so let's do that again. Example 3. A brand new car purchased from a dealership has a price tag of $25,000. As soon as the car is driven off the lot, the car begins to lose its value. The recorded data relating the age of the car and the value of the car is represented in the graph below. Examine the graph and answer the questions. All right, so here we go. Once again, we're looking for the value of the y-intercept. So again, that's where our line, we have our y-axis here. It's even labeled. And there's our x-axis. And so I look where our line hits the y-axis. And in fact, it's at 25,000. Big number. Okay. B, what does a y-intercept represent in this situation? So I'm looking over at my blue point, and it says the value of the car is 25,000. And if I move down here, the age at that point is 0. So the y-intercept actually means 25,000 is the cost of a new car. We have the value of different values of cars at different ages, but our y-intercept happens to represent when it's brand new. Does this graph represent partial or direct variation? And explain again. Well, again, we're looking at 0, 0 as our point where the car is 0 age and 0 value. Well, that's not happening. And so again, because our point does not go through the point 0, 0, we have partial variation. The line does not go through point 0, 0. Whoops, 0, 0. Okay. Find the slope of this line. Okay, so again, when I'm finding the slope of any line, I need 2 good points. So I'm going to go with my y-intercept here. And I'm also going to go with my endpoint there. All right, so if I want to find that slope, again, I'm going to have to move over. So I'm going to go over. And then I'm going to go down here. Going down. Okay, we're going to have negative here. So I could count the spots, but again, that's not going to help me. What I'm going over from here is 0 years all the way over to, let's see here, 4 years. So I have moved right 4 years. So my slope, my run is 4 years. Okay, now the rise or lack of, I'm at a height of 25,000. And I'm going down to a height of 15,000. Now the difference between those two is 10,000, but I'm going down. And I'm going down 10,000, and the units here are dollars. So because I'm going down, I put a minus sign, minus 10,000. And again, dollars. Now to find that slope, I'm going to take my negative 10,000 and divide it by 4, and I get negative 2,500. But the units here are, dollars are on the top. Division, again, means per year. There we go. So there's our slope, minus 2,500 or minus $2,500 per year. What does that slope represent? It's telling me the value of the car decreases, because we have a negative sign there, at a rate of $2,500 per year. That's what that slope's telling us. All right. Now, we found the slope, we found the y-intercept. So the next step here is to find the equation of the line. And again, here's our slope. There's our m value right there. Our y-intercept, b value, let's see here, we go up. The y-intercept is 25,000. So the equation of this line is going to be y equals, slope is minus 2,500. We put an x there. And then our y-intercept, which was positive 25,000. There's the equation of our line. Now, let's see here. F. We found the equation. Now we're going to use it. use the equation to find the value of the car. I'm going to do this one after 6.5 years. All right, so once again, I'm going to write down the equation on my line here. Y equals negative 2,500x plus 25,000. All right, so again, this 6.5 years, that is either my Y or my X value. And if I'm unsure, I can go up to my graph, and years is on my X-axis. So that is my X value right there. That's 6.5. That's my X. All right, so I'm going to substitute into my equation for X, because that's what I got here. So I got Y equals minus 2,500 times 6.5 plus 25,000. All right. Again, the variable's already separated and it's isolated. So I get negative 2,500 times 6.5. So a negative times a positive is going to give me a negative answer here. And I get negative 16,250. Plus, can't forget that, 25,000. All right, and now I add those two numbers together. See here, I get negative 16,250 plus 25,000. Make sure I get enough zeros in there. And it looks like the value of this car now is $8,750. All right. The next one. Again, different question, same situation. So there's my equation again. Y equals negative 2,500x plus 25,000. All right. Now it says use the equation, find the age of the car. So this time we're looking for X. If the car has a value of being, and I'm going to do this one here, worthless. Wow. Well, if it's worthless, the value of your car is 0. All right, so I've got my Y, I'm looking for my X. So I'm going to substitute in that 0 in for Y because our car is now worthless. And so I have a minus 2,500 times X plus 25,000. All right, so this time I do have to get my X by itself. I have to separate things. So I got a couple different things I could do, but I'm going to move my X over to one side, leave my 25,000 on the other. And so again, when you're changing sides, you change signs so that minus 2,500X is now going to become positive 2,500X. And it's going to equal 25,000. All right, so last thing to do is to isolate the variable. So I'm going to divide both sides here by 2,500. All right, and so my X value, how old's my car before it's worthless? Well, let's see here. 25,000 divided by 2,500. And I get 10 years right on. And then this car is basically worthless. Although every car is at least worth scrap metal. But in terms of driving, this car would be worthless. And every car has a value. This car in particular here was losing 2,500 per year. Every car has a different value. And they actually have a slope, if you will, they have an equation for every car. That's actually true. I think it's called a black book. I mean, somebody's parents might be a mechanic, but there is a book value on a car.